So now this problem says a current flows along a lengthy thin ball tube of radius r and with a longitudinal slit of width h. So let us say we have a cylinder, and this cylinder is a infinitely long cylinder. So there is a current in this cylinder. So there is a current, let us say I is the current, that is upward direction. Now the question says there is a longitudinal slit of width h. So I have to have a width here, slit. So let me make a slit here. So for you it will be difficult, I can rub easily. So you have in somewhere here you have a slit, and this slit goes up to here, and this slit is also again here. Okay. So this slit I have to have something like this, and this is something like this. So there is a slit width is given to you, that is h. So slit width is h. So if you look from the top, it will look something like this. So you will see, so this is the top view of cylinder, but there is a width of, so you will not see something here. Are you getting it? So there is a opening, and this width of this opening is h. Are you getting? And what is my task? My task is to calculate magnetic field inside this cylinder. So how we will proceed? So we will use the idea of superposition. So this is equivalent to, so this system is equivalent to, if I have a current in this system, and then I will have, there is no current or a negative current in this direction. So you have a current in this case, that is inward, and in this case you have current that is outward. So you have a something like this. So this is what I am saying. Are you able to understand or not? So what I am saying, this system is equivalent to, you have a cylinder, and this cylinder contains a current in this direction, and there is a wire, basically this wire carries a current in the downward direction. And now if you add these two systems, it will have equivalent system something like this. There is no current in this region because plus and minus gets added, and then you will have a cylinder. Are you getting or not? So this is your cylinder. Are you getting? So this is, now we will use the same idea. Now I will assume this thickness is so small, so in this case I have current I. So let us say if I have this situation, what is the magnet? So this is my center. What is the magnetic field inside? So magnetic field inside is 0 for any point. Are you getting or not? So you follow the Ampere loop law. So if you make a Amperian loop, and if you find the current inside this is 0, so magnetic field inside any point is 0. Now to this wire, so let us say this wire here I have at any distance r, I know. So this distance r is basically mu naught I by 2 pi r, but the current in this case is I dash. Are you getting or not? So let us say, what is my target? My target is to find total magnetic field, and let us calculate this as a B1 plus B2. Are you getting? What is B1? What is B2? So B1 is magnetic field due to this part, and B2 is magnetic field due to this part. Are you getting or not? So this is the magnetic field due to this part, and this total is magnetic field B. Simple. Are you getting? Now B1 is 0, and what is B2? B2 is nothing but mu naught I dash by 2 pi r. R is the distance from this to any in point. So now I can write, so this is equals to 0 plus mu naught I. So this is mu naught I dash divided by 2 pi r, and r is the distance from the slit. Now you see the total length of this wire periphery is 2 pi r. So I will assume if you have 2 pi r, current is I. Basically there is assumption. It's not 2 pi r. So this length is 2 pi r minus h. 2 pi r minus h has current I. So 2 pi r minus h has a current I. So per unit length, this is the current. So h length will have how much current? So h thickness will have this multiplied by h. This is basically I dash. But now I dash is approximately equals to, because h is very small with respect to this r, so I can write this is equals to I h divided by 2 pi r. Are you getting or not? So if I plug this value, so this becomes mu naught by 2 pi r, and this multiplied by I h divided by 2 pi r again. So this becomes mu naught I h divided by 4 pi square r square. Simple. Are you getting or not? This is basically, there is a mistake. What is the mistake? This r is capital R. So this is given to you. So this r is capital R. And this r is a small r. So where I have to find? So this r is a capital R, because 2 pi r is the capital R. So I have to write everywhere this is the capital R. Are you getting or not? So this is capital R. This is again capital R. So let me write. So this is 2 pi r. This is again 2 pi r. And I have to write here this value is r, capital R. So if I plug this capital R, and here I have to also write, so let us say capital R. So this becomes 4 pi r square, r into r. Are you getting or not? So this is the same answer. You have mu naught I h 4 pi r square r into r. So mu naught I h 4 pi r square r into r. What is the important point we have in this problem? Important point is superposition. We have to find what is the magnetic field due to this system. So what is the magnetic field due to this cutted cylinder inside any point inside this cylinder? So now I will think this is same as, so this system is same as, so there is a current in the upward direction in this case. Along the periphery you will have current. Now I will think this system is same as, let us say there is a whole cylinder, complete cylinder, that has a current I in the upward direction, and there is a width h that has a current in the downward direction. Now if you add these two systems, so there will be a space where there is no current, so you will get this system. Now for any point, inside point, there is distance r, a small r from this slit, there will be no magnetic field due to this one, because there is no current inside. But this one acts as an infinitely long wire. So due to this, at a distance r, I know the magnetic field, that is mu naught I by 2 pi r. Only thing is I this time is not total I. I this time is, let us say, I dash. So we can calculate I dash. If this is a total current I, that length is 2 pi r minus h. So 2 pi r minus h has current I. So what will the current that will be taken by h? So this is the current. Let us call this I dash. Now the I dash, this h is very small, so I dash can be also written as something like this. Now things are easy, so we have to apply superposition.